The following is not for mature audiences. This movie is intended to review trigonometric identities. My goal is to create a complete review that would also entertain you for an hour. Enjoy.
Mathbyfives, somebody stole my grade!
Yeah, rumor on the street is Trigva, the trig god, has been killing GPAs all across the country.
Can you help me?
Let's see what you can do. You'll have to prove yourself.
How do I do that?
Let's see what you can do on this entry-level proof. Come on, Han, save Princess grade. Trigva's thrown this at us? Let's prove it. We write the left-hand side, because we're not lazy. That's the cotangent of theta divided by the cosecant of theta, and then how you gonna go about proving that?
Ratio.
Oh, is that right?
Reciprocal.
Okay. Ratio and reciprocal identities. Rewrite them. The cotangent ratio identity. The cosecant reciprocal identity. And maybe you've heard the rhyme, the hum, the hymn. Dividing by a fraction is the same as multiplying by the reciprocal. Fight 'em, fight 'em. Oh, is it? It is the right-hand side. Okay, looks like you have the basics down, and looks like you've seen some of my videos.
Yeah, you helped me with the trig graphs. They were kicking my butt. That's why I came to you.
Those graphing videos are some of my favorites. Let's go to work. Let me show you where the Pythagorean identities came from.
The Pythagorean identity! We're gonna need a couple of things. Oh boy! We have our right triangle, right? And long well established 2,000 years ago, x squared plus y squared is r squared. Now, if we're gonna need the Pythagorean identities, we're gonna need a couple of things. These guys, I have the sine of theta is the opposite over the hypotenuse, and the cosine of theta is the adjacent over the hypotenuse. So what do I need to do? I need to tie this up by dividing both sides by r squared, r squared, r squared. And then I'm gonna have x squared over r squared plus y squared over r squared. That's gonna be equal to 1. Now, this guy can be written as x over y r squared plus y over r squared, and then that's equal to 1. Now, what do we need? We need these two guys. Y over r is sine, x over r is cosine. So, I go and I throw those in there. X over r, that's the cosine of theta squared plus the sine of theta squared. That's going to be equal to 1. I'm going to take it to the top. And we're gonna get the first of our Pythagorean identities. Trig is notoriously lazy. So, the cosine of theta is also written as the cosine squared theta plus the sine squared theta. That's equal to 1. Fun. Now,
Due to the length of the following example, we must proceed in lecture. If you would like to see this in actual time, please click the annotation below and you will be taken to the full-length video. But until then, enjoy!
squared theta, and that's the third of our Pythagorean identities.
Alright, I've shown you where the Pythagoreans come from. Now, let's see if you can handle them in some proofs.
Okay, Mathbyfives, I came to play.
You gotta work to save that princess. You're gonna write down the left-hand side of this proof, because you're not lazy. And you do. Cosine alpha over secant alpha plus sine alpha over cosecant alpha. Let's see what we're gonna use.
Reciprocal.
Oh! What else?
Reciprocal.
Yeah! And we do both of those, rewriting those denominators using our reciprocal identities. What comes next? Maybe you've heard that rhyme, that hum, that hymn. Dividing by a fraction is the same as multiplying by the reciprocal, and that's how we get the cosine squared plus the sine squared. Now this is gonna take a trick. What am I gonna use?
Pythagorean.
Oh! How's that work?
Pythagorean.
Oh! And yes, indeed, that is the right-hand side. Okay, so on that last one, we got to talk about two reciprocal identities, the one for secant and cosecant. We also got to talk about two different versions of the Pythagorean. Excellent. Also, we got to talk about a common proof strategy, starting on one side and showing the other.
Mathbyfives, I'm so glad you decided to help me. I don't think that I can have done it without you.
Well, Stu, don't get ahead of yourself. This isn't gonna be easy. We have a difficult path. We're gonna save the princess. This is a proof. Look at what we have here. On the left-hand side, we write it down. We're not lazy. We have 1 minus the cosine over 1 plus the cosine. And we're going to try to multiply top and bottom by the conjugate. Look what this guy's doing. He's multiplying by the conjugate in the numerator. Let's see where this takes him. Alright, so top and bottom by that. It's the magic one. Now what? Multiplying out that top, you see you have the difference of squares. A plus b, a minus b, multiplies out to be a squared minus b squared. Now what? In the denominator, go ahead. Perfect square. Show me. A plus b squared is a squared plus 2ab plus b squared. Now, where are we at? I don't know. I'm trying to get that right-hand side. This is trash. Let's start over. That's a legitimate strategy. This time, let's multiply top and bottom by the conjugate of the denominator. Go ahead. Multiplying top and bottom by the magic one, or 1 minus cosine squared, or 1 minus cosine divided by 1 minus cosine. When we do that in the numerator, whoa, why don't we just square them. Good idea. Because if you have something times itself, it's itself squared. And the denominator, difference of squares. Nice. Well played. Now what are you going to use? Your training.
Pythagorean.
Yeah. Wait, how did you do that? Oh, you got that sine squared in there using algebra. Alright, I see. Oh, yeah, split the fractions. Nice idea. Wait for it. Wait for it. Yeah! Why?
Reciprocal. Ratio.
Nice. How you gonna get there? How you gonna get there? How are those the same? Oh, I see. That's that difference squared. Wow, there was a lot going on in that last video. We talked about proof strategies. And a good one is, when you get stuck and it looks like it's not going where you want to, Start over. We also got to multiply by the conjugate. You use that so much. And algebra. You use the perfect squares. Multiplied that out. Difference of squares too. You also did some arithmetic. You split fractions. You saw x squared is x times x, and a quotient raised to a power is the powers to the quotient. Also, the difference squared is the same as the difference squared in the other order.
Mathbyfives, there sure is a lot of algebra. Kinda scares me.
Relax, Stu. You're gonna be okay.
When they got there, they found a female victim of a homicide that had been shot. They found a male suspect or subject that had been shot multiple times. He was transported to the hospital shortly after.
Trigva's getting pretty serious. We're expanding these guys out in this proof. Yeah, so I'm expanding out that first binomial. I'm using a perfect square. Which one? This one. If you have the sum of a and b and that's squared, that's a squared, plus 2ab minus plus b squared. Now, I want to expand out that second one. Sure. I know I see you're a little short of room. That's 4 times the cosine squared minus 4 times the cosine sine plus the sine squared, because we're using the perfect square for the difference of a and b. A squared minus 2ab plus b squared. Now, we need to gather, collect, and combine. We see we have additive inverses. Those go away. Now, let's rewrite what we have so we can see what we're doing. That's 4 sine squared plus 4 cosine squared. Nice. Oh, I see what's going to happen here. Cosine squared plus sine squared. Oh, use your training. Use your training. How are you going to get what's next? Factor out that 4. All right. And then this happened. Use it. Use it.
Pythagorean.
It's the Pythagorean. Cosine squared plus sine squared is 1. So, we evaluate each one of those, and we have 4 times 1 plus 1. It's the right-hand side.
Oh my god, Mathbyfives, those two people that tricked me killed their grades. They were my friends. They were my friends.
Relax, Stu. Let's focus on what just happened.
They killed them.
No, not that part. We use the perfect squares. We also use factoring. We used the Pythagorean several times in that last proof. Also, there were additive inverses from algebra. The number that when added to the number the sum was none. And we used arithmetic.
Alright, Mathbyfives, I'm ready.
So you need more skills. You need more tools in order to beat Trigva. Let me show you the proof of the cosine of the difference of 2 angles.
Who's ready to prove the cosine of the difference of angles? This guy. What am I looking at? I'm looking at the cosine of the difference of these 2 angles. What's it going to be? It's the cosine of A, cosine of B. These are the same. The signs are different. The sine of A, the sine of B. And then we need to get a nice tight shot of this over here. Okay, not that tight. Right. Let's come back over here. If we're looking at our unit circle and this is the angle B, then that point right there on the unit circle is the cosine B, the sine of B. Alright, and then if we're looking at this A, that point right there is the cosine A, the sine of A. What's the key to this is the distance between these 2 points. I want to perform an angular transformation down here. I've taken that guy where this is the difference of angles, and I'm taking this little white line and I'm putting it right here, and I'm claiming that those distances are the same. I just went and I went dink. And that's where I'm at there. So, the claim is these distances are the same. So I'm going to need my distance formula here. So, that's the difference of the x value squared plus the difference of the y value squared. And then we're going to take the square root right there. So, we need to look at these points. Alright, so the distance from this one here to here, this is going to be the square root of, wait for it, the difference of the x's. That's the cosine A minus the cosine B, and then that dang thing is going to be squared. And we're going to subtract off the sine of A minus the sine of B. Whoa there. My colors got switched, but I think you know what I'm talking about. The sine of B squared, that guy right there. And then that's going to be equal to this distance right here. So, can you see that behind me? Right on over here? Whew, I'll go backhanded. Yeah, because this is going to be equal to, can you see? No, that's behind my head. Okay, I'll go forehanded. No, I'll go over here. So then, yeah, that's the square root of the differences of the x's. That's the cosine of A minus B, and that should have been in blue, minus 1. That whole dang thing is going to be squared, and then minus the differences in the y's. So then this one's in blue. This is the sine of A minus B, parenthesis, minus 0. And then that dang thing is going to be squared. Get that root right over there. All right, I'm over here.
Due to the length of the example, we must move forward in lecture. If you would like to see this in real time, please click the annotation below. You will be taken to this video in its full length. Enjoy!
B. Now stay with me. The only thing I have left to do is divide both sides by that minus 2. And when I do, I'm going to get that the cosine of A, cosine of B, plus the sine of A, the sine of B. That's going to be the cosine of A minus B. And what do we see? This guy right here, where the cosine of A minus B is that stuff. It has been shown.
Trig is no joke, Stu.
I see that, Mathbyfives.
I just showed you one of the more technical proofs in trigonometry. What I'm going to need from you is I'm going to need you to know those forwards and backwards.
I'll do what I can, sir.
Oh. So you want to evaluate cosine 40, cosine 50 minus sine 40, sine 50. What are you going to use? Oh, you're using the cosine of the sum of angles. I see. It fits the form right there. So, if it fits the form, we can just write that right-hand side. Nice work. Add those two. What are we going to get? 90. Nice angle. What's the cosine of 90? Sucker.
This stuff makes my head hurt.
I know, Stu. But I'm going to need you to know those forwards and backwards. So let's see what you can do on this next one. With trig, you can do some fancy stuff. I'm going to need you to find this next angle exactly. Well, the sine of it.
I'll do my best, sir. My brain's gonna explode.
So you're trying to evaluate exactly the sine of 13 pi over 12. So you're going to have to break those up into known angles, or radian measures anyway. Now this is an art and a talent. You're going to have to practice to get good at it. Looks like 13 is 10 and 3, and both of those are over 12. Reduce them. Oh yeah, that looks familiar. Looking good. Nice. Now what? We're going to expand that out using the sum of sine angles. Alright, that's the sine A cosine B minus plus, yeah, there you go. Alright, cosine A sine B. Now, we're going to put those in exactly. We're going to match our A's and we're going to match our B's. Alright, good, nice, that's B. Alright, and then finish him. Oh boy. There you go. Now, we need to evaluate those guys. What's the sine of 5 pi over 6? Half. All right, it's in the second. It's positive. And then the cosine, yeah, over 4s. People know those. And now u goes. Ah, that one's negative because it's in Q2. Now, let's clean up those fractions. One last step. They have a common denominator. Add 'em. That went much better than the last one. Good job.
I am the king. I am the king. I'm all shook up. Yeah, yeah.
All right, Stu. I'm going to need you to focus because we're about to get highly technical with right triangle trigonometry.
Yeah, I'm ready. With my blue suede shoes. I'm gonna get 'em.
All right, Stu. Don't get cocky. We're trying to find the tangent of s plus t. They give us some information. All right. Now, the tangent of s plus t is the tangent of s plus the tangent of t divided by 1 minus the tangent s tangent t. Now we are going to construct our triangles with our given information. Triangle S comes from the cosine of S is minus 8/17. The cosine is ka. That's the adjacent over the hypotenuse, so that's a minus 8. That's a 17, and we use the Pythagorean to complete that triangle. That should be a minus 15 because S and T are both in Q3. Now let's make it for the T triangle. Again, it's ka, so we go and we labeled the adjacent side minus 3 and the hypotenuse, that should be a minus 4 too, also, in addition. Now, let's fill in these guys using the opposite and the hypotenuse, the tangent of both of those triangles appropriately. The opposite is 15 and oh, that should be a minus 15. Keep going. And then use triangle T. Go ahead. Triangle T for the tangent of T, and then we see that this is going to be a minus. That should be minus also. 1 minus. Oh, that should be plus. That one too. Alright, so now we've goofed up, and you probably want to rework this a couple times knowing now that you have this information. But let's throw this into a calculator and see what we get just in case the signs corrected themselves. They probably didn't, and there goes your bad edit. Alright, and you're done. Pull it together. Oh my god, Stu! What happened on that last one? You fell apart. It was wow! I mean, the signs were, oh!
I'm sorry, sir. We partied a little too hard last night. I don't know. I gotta feel.
Stu, pull it together. You need to think about your grade. What's more important to you, that party or your GPA? I'm going to need you to focus. I'm going to need you to get back on the wagon.
I'm gonna try my best. There's a lot going on.
Let's see what... Oh! Let's see if you can handle this next proof. So we're trying to prove the sine of x minus y divided by the sine of x plus sine of y. That's going to be tangent x minus tangent y divided by tangent x plus tangent y. That's why we rewrite the left-hand side because we're not lazy. Sine of x minus sine of y divided by the sine of x plus sine of y. Then we're expanding out the sine of a minus b. That's going to be sine of a cosine b minus sine of b cosine a. Then the sine of a plus b is going to be the sine of a cosine b minus plus the sine of b cosine a. Okay, now on that left hand side we're going to go and we're going to expand out that guy. The sine of x minus the sine of y. That's the sine of x cosine y minus the sine of y cosine x. What's next? Divided by that sum. The sine of x cosine y plus cosine sine of y. Why? Oh! When you redo this proof, make sure you catch that part. What are you going to do now? You're going to divide both top and bottom by cosine x cosine y? Why? Oh, because we're trying to get the tangent in there, and the tangent's the sine of the cosine, so it behooves us to divide by cosines. And we go and we do that. In the numerator, we take sine x cosine y, and we divide it by cosine x cosine y minus, same thing. Then, do that to the denominator too. Alright? The sine x cosine y, sine y, cosine y, divided by cosine x, cosine y, cosine x, cosine y. And now we're left with dramatic reduction.
We are the VSA. We uphold the sanctity of life. We shield the weak. No innocent shall fall. We will never know defeat.
We see an innocent did fall, but what are we left with? A whole bunch of ratio identities. Yeah!
Ratio.
Do it. Okay, sine x over cosine x is tan x, tan y. Now see that guy? It's off due to a fat y, but that's not the main problem in your proof.
We are the VSA. We uphold the sanctity of life. We shield the weak. No innocent shall fall. We will never know defeat. Class 94. Let me be the first to call you Shadow Marshal.
Finish him. Redo it. Stu, last time we talked, I got a little mad at you, and I'm sorry. But what's going on?
I got a lot going on in my life right now. I work full time. It's just, and I got a lot of, my family life is just, it's in the crapper, and I'm just,
Stu, I have a lot involved with you too. I mean, I'm sacrificing a lot. I'm spending a lot of time with you. Girl I was seeing left me. Coworker mad at me. All because I'm spending a lot of time with you. I need you to pull it together. We're gonna save the princess. Princess grade.
I understand that, Mathbyfives, but I'm trying to tell you, I think I'm gonna quit.
Whoa! I cannot have you quitting on me right now. We are too far into this for you to quit.
Alright, I'll try, but I can't promise anything.
You make your promises.
I don't know.
Let's see what you can do on this next proof. We got a lot of work to do to heal your grade. You gotta lose yourself. You gotta own it. You only have one shot. This is your opportunity. Let's go. Somebody once told me that one of the biggest skills you learn in college is time management. So come on, Stu. I got a lot riding on you. So we're trying to prove the sine of the difference of angles divided by the sine of b plus the cosine of the difference of angles divided by the cosine of b is gonna be the sine of a divided by the sine of b, the cosine of b. We rewrote the left-hand side because we're not lazy. So now we expand that out. The sine of the difference of a and b is gonna be the sine of a cosine b minus the sine of b cosine a. Yay. Didn't goof that up like in the last one. Anyways, I'm not bringing up old stuff. The cosine a minus b, that's gonna be the cosine a cosine b plus the sine of a sine of b divided by the cosine of b. Now what do we want to do, see? Add those fractions. So we're going to have to multiply each one of those by 1. Cosine over cosine and sine over sine, respectively. So now we do that. When we take that cosine times that binomial in that numerator to that left-hand side, it's going to distribute in. And you will have the cosine b times that first term minus the cosine b times that second term. And then we're going to take that and we're going to divide it by the common denominator. Now, we're taking a look at that second term. We're multiplying top and bottom by the sine over sine. So when we distribute in that sine to the top, it's going to go to both of those terms. And it does. That's the sine b times cosine a cosine b plus the sine b sine a sine b divided by that common denominator. And now that we've achieved common denomination, we're going to go and we're going to add their numerators. Well, we can also clean them up, because cosine b times cosine b is going to be cosine b squared. Alright? And then we have that other term. Nothing cleans up in there. And that other term, nothing cleans up over there. But sine b times sine b is going to be the sine of b squared. And that's what's happening right there. Oh, look at that. All over that common denominator. Now what do you notice in that middle term? Oh! Additive inverses, that's the number that when added to the number, the sum is none. They're gone. I see in the remaining part we have a sine of a common to both of those, and we factor that out. But, oh, look at that! How could I look at that if I can't see that? Yeah. You made a mistake somewhere, huh? Oh, oh, there. B, B, oh, B, oh, oh, B. One more B. And then now, can we see?
Ladies and gentlemen, whoever is in the crowd is well started this contest at 3 minutes, 21 seconds into the 31st round. Declare your winner by
I'm glad you didn't give up on me, Mathbyfives.
I know. And I'm excited about it too, and I really feel like we turned the corner on that last proof. There was just that one little thing, and looks like you got it under control.
Yeah, I was able to reconcile with my cousin and get my shift switched around a little bit, but other than that,
Yeah, let's get back to the math. On that last one, we had to do a lot of things, including adding rational expressions, which was, yeah, wow. And additive inverses, wow. And then you finish it, wow. And you bounce back, wow. I'm so proud of you. I can't see what, you know, let's level up. I'm hesitant, but let's take it to the next level. Let's go with double angle. You ready? Let me show you where that comes from. Actually, why don't you come sit in one of my classes?
You ready? You ready? You ready? You ready? You ready? I'm ready to go improve this guy. Oh boy! We're dealing with the double angle identity. We're gonna need this guy over here. So I have the sine of the sum of angles. That's the sine of A, the cosine of B. These are different, so the sines are the same. The cosine A, sine of B. And then what are we going to do with that? We're going to break it up in the algebra style. What am I talking about? I'm talking about this. Ooh, I'm going to call that the sine of the sum. X plus X. Wait a minute. What's X plus X? It is 2X. Finish him. Now it's plug and chug with that guy over there. So I'm looking at the sine of X, the cosine of X, because I'm considering this my A and that my B. So then these are the opposites, so these signs are the same. This is plus the sine of X, the cosine of X. But that one over there has the cosine of X and the sine of X. Yeah, but I can commute the two because it's multiplication of two functions. Do you guys see anything to like there? They are the same. So, like here I had an X and I had an X, a couple of them. Yeah, I can rewrite that as 2X. Here I have a sine, cosine, a sine, cosine. I can rewrite that and a sine, a 2 in front of that. 2 times the sine of X, the cosine of X. And then what's next? That's it. That's the sine of the double angle.
wow, Fives, I wish I was in your class.
You kind of are, Stu. We're getting you all trained. You're going to save the princess. Princess grade. Well, alright, so now, in order to save princess grade, you're going to have to train.
What am I going to have to do?
You're going to have to work with this double angle.
This is going to be out of this world.
Get 'em. We're going to find the sine of 2 theta, given that the sine of theta is 2 fifths and the cosine is less than 0. You expand out that, and then you create your triangle with the known information. Complete it with the Pythagorean. And you knew it was in quadrant 2 because the cosine was negative and the sine was positive. So now, you're going to go and you're going to fill in what you know. You know the sine of theta is 2 fifths. you read off your triangle that the cosine is minus 21 fifths. Now you multiply and you clean that up, and I'm proud of you. Fancy status. Get 'em! Nice work, son. Looks like you're using those outside negatives as positives.
I know, I'm getting it. I'm getting it. I like to work with the negatives. It makes for a better picture.
All right, sure. So you're a little weirdo, and you shout out to Drake. So anyway, I'm gonna need you to buckle down because this stuff is gonna get a lot harder. Now we're gonna go with right triangle trig. Struggled with that before. Let's see how you do with it now. Let's go find the sine of theta if the cosine of 2 theta is a minus 5/12 and theta's in the second quadrant. We're gonna use the
Double angle.
yeah, and we write it out. We know what the cosine of 2 theta is, and we'll put that there. You have taken a few big shots. Now let's take a shot at solving this. You subtracted the 1 off each side, and now you're about to divide both sides by that minus 2. You did drop them. You dropped both the minus 2 and the square root on them. So now, let's go ahead and let's clean up that root on the right-hand side, but first let's assign that sign. Now, theta is in the second quadrant, so what are we going to do? The sign is what? Where's the sign? The sign is positive in the second quadrant. So now let's rationalize that denominator. 17 times 6 is 102. All right, show me. Box and flower. Nice work on that last right triangle problem. Wait, Stu, what are you wearing?
I'm just wondering which one we're gonna do next.
Oh, God. Wow. Famously bad. Well, let's see how you do on this next proof.
You can count on me.
So we're trying to prove the sine plus the cosine squared is the sine of 2x plus 1. Now, you put with the left-hand side, and I see that you're still using that Abrams effect. Thanks for getting rid of it. We multiply that out because that's a binomial squared, and when we do, we get that. Now let's reorder these terms. Oh, we're almost done. Knock him out. Finish him. That's 1, isn't it?
Ladies and gentlemen, whoever we get for the audience, don't stop this contest. 1 minute, 17 seconds in the very first round. Declaring winner
That's the right-hand side, and I'm tapping out of this problem. Stu, are you trying to go Super Saiyan?
Yeah?
Here, I'll go with you.
He's gone Super Saiyan.
We are trying to prove the tangent of theta times the cosine and squared theta is going to be 2 times the tangent theta cosine squared theta minus the tangent theta all over. 1 minus the tangent squared of theta, so then we write that more complicated right-hand side. And then we see that there's a common factor there, see? There's a tangent in both of those, and that glows, and I knows you don't like that, but I like the glow, and it's all over. 1 minus...
Ratio.
Oh, don't go away. The tangent squared theta, which is the sine squared theta over the cosine squared theta. And now what are we going to do? We're going to go and we're going to add the fractions down there in the denominator. And you're like, why? And I'm like, wait and see why. So we go and we add those two, getting the cosine squared over cosine squared times that 1 minus the sine squared over the cosine squared. Then it's going to be all over the cosine squared because you'll achieve a common denomination. Now what? Well, there's a couple different ways we can go. We can use the reciprocal, or we can use the double angle.
Double angle.
Haha! Double angle. All over the cosine squared theta. Alright.
Ada mixing things into a shot here, trying to get a double leg on.
Awesome, you caught that, you caught that, you caught that. Why? Because you're going to need to reduce 2 times the... You're multiplying by the reciprocal, and then that's 2 times the cosine squared theta minus 1. You have bounced back quite nicely, sir. You did counter well, because now we have the right-hand side. I mean left. You did well on that last one. You know, one time, I messed up in class on that problem. That's how it got to your training. That's how it made it. Alright, so, now we've made it to the next level. Let's go back to class, because we're about to prove the half angle.
That sounds super!
Selfie! What do we want to do? We want to prove the half-angle identities. And what are we going to need to use?
Double angle.
We're going to need to use the double angle for cosine. So here we go. We're going to go and we're going to solve that dang thing for the cosine. So I'm going to have the cosine 2x plus 1 is equal to 2 times the cosine squared x. And then, still solving for the cosine, I'm going to divide it by 2. And I'm going to have the cosine 2x plus 1 all over. Deuces. And I'm about to say bye-bye to that cosine. Squared x. What's next? How do I get rid of that cosine? I mean, how do I get rid of that square? I'm going to take the square root of both sides, but I'm not going to forget the plus or minus the square root of the cosine squared, or cosine 2x plus 1 all over 2. That's going to be equal to the cosine of x. Wow! We're trying to make the half-angle identities, and I don't see any half-angles in there at all. I'm going to take it to the top. Oh yeah, right on over here. I have the cosine of x, and that's equal to, wait for it, plus and minus, the square root of the cosine of 2x plus 1 all over. Deuces. I want to make a substitution. Yeah, put me in, coach. I want to let x equal a over 2. And when I do, everywhere I see an x, I'm going to put an a over 2. So there's an x. So I put the cosine of a over 2. And then that's going to be equal to plus and minus the square root of the cosine of 2 times a over 2. And then plus 1, fun, all over. Deuces. We're almost done. So the cosine of a over 2, that's gonna be plus and minus the square root. Now I have 2a over 2, which is just a. Okay. So that's the cosine of a plus 1 all over 2. And there you go. It has been shown.
Stu, the half angle is no joke.
Sorry for clowning around, Mathbyfives.
I'm going to need you to focus, and I'm actually going to need you to train. I'm going to need you to train and get ready to prove the half-angle identity. This is the last level, and Trigba can get real serious.
Why so serious?
Sine of 15 degrees. What are we going to use?
Half angle.
That's right, the half-angle identity. 1 minus cosine over 2, we're going to take the square root of that. So now, half of 30 is 15. That's why we're using 30. plus or minus, don't want to forget that part. But theta's in Q1. I don't know why you wrote Q2, but 15 degrees is in Q1. So we're going to strike out that negative sign because the sign is positive in that coordinate. Now, we're evaluating this. The cosine of 30 is root 3 over 2, and then that's all over 2. Now we do some algebra. Alright? There you go. And you're done.
I am a math artist, a Picasso with a Pythagorean.
Alright, Stu. Now, that last one was a creative use of the half angle, but let's focus on the math.
Oh, bro, come on, bro. You know I'm good, bro. Let's go, bro.
Alright, bro. Let's see what you can do on this next right triangle half angle identity evaluation. We're trying to evaluate the tangent of that half angle, and we're given a couple of things. The tangent of theta is root 7 over 3, and theta's in the third quadrant, so we expand out that half angle.
Half angle.
And when we do, we're going to create our triangle.
Belfort has looked absolutely spectacular in his last few fights. Physically, he's never looked better. He seems more motivated than ever before. He seems more confident.
We create that triangle with our given information. Pythagorean completes it. And now we're going to fill in the information. The sign on that triangle is the opposite over the adjacent, and that's how they get the opposite over hypotenuse, my bad. And that's how they get that, and it's negative in the third quadrant, so they read off the cosine, ka, 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 but I think that's negative down there. Anyways, I'm sure you'll catch that later. Alright, rewrite the numerator. What's in the denominator? Aha, got it. Alright, focused. We're gonna get this. That's the square root of, oh, you're adding those fractions in the denominator, great. I don't know what the applause is for. The multiplication of the reciprocal? That's what they're doing. Cross out those, and then we have that. But it's not over yet. Because, you know, like all books, we need to rationalize that denominator, multiply it by the conjugate. So then we get the square root of 26 plus 3 over the square root of 26 plus 3. Good, good. Alright, that numerator? Nah. I think you forgot the root somewhere. The root of 17? Use the difference of squares on the bottom, good. There you go. Didn't mean to interrupt you. Alright, clean it up. We're almost done. Seems like you got a lot going on there. And you're done. Oh, look at that. Look at that. It was in the palm of your hands. Looks like you bounced back from your right triangle woes.
There's two groups in this Mathbyfives. Those who enforce it and those who litigate on it. Dun.
Wow. Alright. You want to impose a little law and order on this next proof, huh?
Yeah, I'm gonna make it law.
Prove the secant squared of the half angle
Half angle.
is equal to 2 over 1 plus cosine. You rewrite that left-hand side, and you're using the reciprocal identity. And then the
half angle.
half angle. But remember, cosine squared is the whole dang thing squared. 1 plus the cosine of x over 2 squared. Now, that square is going to take care of everything. So, we can go and we can get rid of that root and the plus and minus. Wonderful. And now we use the reciprocal, not the identity, the actual reciprocal. And that's the right-hand side. It's about that time.
Oh boy, homework?
No, the end of work. This is the last proof.
I feel like the whole process has just made me old.
Yeah, well, trig can be daunting, and it can wear on a guy, or girl, or student. Oh, come on, Stu. What is Stu short for, anyway?
It's short for Stuart.
Yeah. Go get that. Alright. So, let's go get this last proof. Let's go. Prove. The tangent of a over 2 is the sine of a over the quantity 1 plus cosine a. So, we rewrite the left-hand side because we're not lazy, and the sine of the half angle of a over 2 is
Half angle.
plus or minus the square root of 1 minus cosine of a divided by 1 plus the cosine of a. So we say that we're going to multiply by the conjugate. You're like, why? Well, why don't we wait and see what we get? So we're multiplying top and bottom by the conjugate. Now, when we do, in the top, we see we have the difference of squares, and when we multiply that out, that's 1 minus the cosine squared a, and down there in the bottom, why don't I just call that a square? Yeah. Now what? Oh, Pythagorean!
Pythagorean.
Then what? Oh, really? You have the square root of a couple of squares and you get the sine of a? Of the cosine of a? That is the right-hand side. But why? Oh, that's the definition of absolute value, and I can get rid of that plus and minus. So now what are you going to do? You've already shown the right-hand side. You're going extra? He's going the distance. He multiplies top and bottom by the conjugate of that denominator. Why? He's going to show you the other form. You are really on. So, they go, oh, difference of squares. Then,
Pythagorean.
Pythagorean. Yeah. There it is. They reduce, and you are left with the other form. You've leveled up. Good job, Stu. Well, Stu, this day has finally come. We knew it was coming. I've seen you grow so much. Along the way, you've had your struggles and your triumphs. I'm proud of you.
Okay, Mathbyfives, let's go kick Trigba's butt.
I can't go with you. I can't fight other math gods. You have to do this on your own. You have to
prove yourself.
But I need you there with me.
Yeah, I get that, and I will be, in your head. I just can't physically be there with you. You're on your own now, Stu. Go save Princess Grade.
I'm gonna make Trigba my bitch.
Damn, Stu. I'd like that.
Unlike a lot of YouTubers, I'm actually a real teacher. I'm sitting here doing math on some old student evaluations. This isn't all of them. I've been doing it a long time. Like 20 years. Well, that's 12 linearly, but for 8 of those I've been working 2 full-time jobs. And I got a ceiling fan. Oh God, oh God! Yeah, you're in good hands.